Okay, welcome those of you who have just joined. On the agenda this evening is we're going to begin inferential statistics. I'm going to introduce you to that. And first on the slate for that is the Pearson's correlation, the R test. Okay, so that's pretty much what we're going to be speaking about tonight. And then in our last content session next time, I think it's the last time, we will go over hypothesis testing and the t-test, and that should wrap us up quite nicely. And then I will also schedule an exam prep session to do some exam briefing and prepping before then as well. Okay, yeah, just want to wrap up the content before we start reviewing it. All right. Okay, are there any questions just before I begin on anything, maybe? If I need to address anything, you can pop them in the chat. Cool, okay. Alrighty, so correlation. Yeah, I'm sure that you have heard this word about, and we use it pretty like common usage a lot in English. We say, there's a correlation between temperature and mood or something. And essentially what we mean when we say things like that is that there's a relationship. So this is what a statistic does, is we attempt to identify and explain the type of relationship that exists between an independent and a dependent variable. Okay, and it measures two things, and there are always two things that you must describe when asked to interpret a correlation score, and that is the strength of the relationship and also the direction of the relationship. So it can be from weak to moderate to strong, or it can be negative or positive as well. And so basically how we deduce this after the calculations is that you will get a number between -1 and 1. And basically the closer to 0 on either side, the stronger the relationship is. Wait, other way around, sorry. The closer to 1 on either side, the stronger it is, and the closer that the number tends towards the 0 mark, the weaker the relationship is. Yeah. And I think the best way to try and explain this is with pictures. I know this one's a bit blurry. It's just, I don't know why I ended up pixelating so badly. Anyway, I have another one. But basically, the graphs that we produce with a correlation are called scatter plots. Yeah, and I mean, it's literally because it looks like someone just scattered their marbles on a table, right? And that's why we call them a scatter plot, pretty much. And because it's showing us how the data kind of is spread out and, like clings to each other and things. And essentially, the closer the dots are together, the stronger the relationship is of the correlation. And then the more spread out that they are, the weaker the relationship. So in this image that's currently on the screen, we've got two strong relationships and then no relationship at all. Like this last one on the right-hand side here is what no correlation looks like. It's just completely scattered. There's no kind of pattern. There's no grouping. And what would happen if you produced that would be that your R value would be 0. Yeah. So when you get an R value of 0, it means that there is 0 relationship. There is no correlation. Okay. Yeah, that's that. Let me go to the next picture. There we go. That's much better. Okay, so essentially the ways that we describe the relationships are kind of also known as the types of correlations, the type of relationships that can be found in the data. Okay, so yeah, so this is quite helpful, this diagram, especially because it's got the trend line in there, the straight line that's drawn through the data. The line becomes particularly important when you do regression analysis and things like that, but that is not what we are here to do. That comes in at a postgrad level with statistics. But for now, it's really nice just for that kind of illustrative purpose. You can see the line, you can see what direction it goes in really easily. Okay, so at the top here on the left, we have a strong positive correlation. Okay, so first of all, you can see that it's positive because the line is going upwards. Okay, so whenever the data is grouped together and it trends from the bottom left-hand side of a graph up towards the top right-hand side, that is a positive relationship. Or in other words, as the x value goes up, the y value also goes up. And that is what a positive relationship is. As the one increases, so does the other. Okay, and so yeah, in terms of strength, we can see, I mean, these dots are nearly exactly along that line. So that is a very strong relationship. This value would probably be very close to 1, probably about a 0.9-ish, if I had to hazard a guess. And yeah, essentially, and the reason why I'm doing this as well is that you can glean a lot of information from a correlation without even looking at numbers if they give you a scatter plot like this, which is possible. You may be given a scatter plot and asked to describe the relationship. Okay. Okay, so we have a strong positive here because the dots are close together and tending upwards towards the top right-hand side. And then this one is a positive correlation, but weaker because the dots are further apart from each other. It's almost like if you think almost of like the line as a magnet, it's like this is a weaker magnet because the dots aren't being pulled closer to it. It's just, that's an analogy I've come across that's quite useful for things like that as well. Okay, and then so what a negative correlation looks like is it goes from the top left down towards the bottom right. Okay. And the logic behind this is that as y increases, x starts to decrease. Okay, and so in terms of variables, if we had to do an example here, let's say we're trying to see if there's a relationship between the number of cups of coffee that you drink and your test scores on an assignment or something. And so what we're really measuring there is the test scores. So that would be along the x-axis. And so we'd say, okay, well, if someone's drinking 10 cups of coffee and their exam score is around here, but then if someone's drinking like 3 cups of coffee, their exam score seems to be higher. So we would deduce some kind of negative relationship from that. So as one increases, the other decreases. It's almost like an opposite situation, okay, where the change in the one variable causes the other to decrease as opposed to increase. I know I sound very repetitive, but I'm just saying it in all the types of ways it can be said, so that it makes sense. Yeah, and then if you look at the bottom here on the left, this picture is a weak negative correlation. So very much in the same as the second one up here. You can see the dots are further away from that central line from each other, okay? And yeah, tending in that direction. And then so this one, they've included because it's a moderate relationship. So you can see the dots are closer together than this one is, but they're not as strong as this first one at the top left. You know, they're not literally falling along the line, but they are fairly densely packed together. Okay, and then no correlation again. Just if it looks like a random scatter, like someone sneezed on your graph, then there's no correlation there. Okay, do we have any questions on this while we're here, just with the visuals, before we get into kind of the numbers and nitty-grittiness? Yeah, I'm very curious about how questions are asked in the exam. I mean, fair, within the specific section. Will we get a graph and be asked to describe details about it? So that is possible. That has been done before. They've provided a graph with some data points on it, and you can be asked to describe what you see there. And so you would have to describe the strength of the relationship and also the direction, and then what that would mean in the given scenario with the variables, you know. So you need to practice not just identifying, but also explaining what you see. So yes, in the top left here, we can see there's a strong positive correlation, but what does that mean? And so what that means over here is that as the one variable goes up, so does the other. Okay? And the way that you explain that, you know, like with the language, depends on the scenario you're given. And I've got an example in a minute that will help with that kind of application. But that is possible. And it's, I mean, that's a really lovely question. You know, it would be quite nice. I have seen it come up before. I've also seen where you have to draw like a rough sketch of a scatter plot, indicating a certain type of correlation. And I mean, that's also quite fun because it's like essentially, it's like a really easy 5 marks in theory, if you like remember these things. No, so if you're asked to, at this level, you would never be asked to plot like an accurate graph, you know, and a ratio and all of that nonsense. You'd just be asked to draw some kind of like rough diagram like this, a generalized one, just to show that relationship, you know. But that is less likely than just having you explain in words. I'm trying to think what they did last year. Can't remember exactly. There was a visual. Yeah. Anyway, sorry, getting sidetracked. We'll speak much more about that in that exam prep session that we're going to have closer to the time, because I will pull some examples from all over as well, so that we can engage with that. Okay, cool. Let me see if I missed any questions. I don't think so. Are there any questions, anyone? Comments? Does it make a bit of sense, or is it all just kind of a lot at the moment? Okay, so what may help is that we need to draw the line between what is correlation and what is causation. And a lot of the time you can falsely assume some kind of causal relationship, right? And that's pretty dangerous in the world if you start to do that. You know, a lot of conspiracy theories are born out of things like that. Yeah, when people make assumptions that one thing causes another thing, whereas it's more likely that there's a correlation. So while we notice a certain amount of events that do occur together, we can't confirm that every time X happens, Y will follow. And so essentially that's the difference. When you establish correlation, yeah, you establish that there is some kind of relationship between variables and incidences and things. But with causation, you're essentially making a statement that says when A happens, B will happen, right? It's like saying if you drop an apple off of a table, it will hit the floor, right? Like we know that that's true because gravity. Another example would be that we know that smoking increases your chances of, you know, getting some sort of cancer or something. Like that is an established relationship. We know that, you know, that's it's kind of an established relationship, but not necessarily that it would happen in every single case. So yeah, again, like you may also be asked just to differentiate between these two concepts. That's also could be like one of those quick little theoretical questions kind of in the beginning of an exam or in the beginning of this section of an exam. Yeah, so that's that basically in a sense, and that's really the difference, is that certainty. Okay. All right. Okay. So please do not be offended by the equation. I know it's a bit hectic, but on first sight, but when we break down the symbols and things, I promise you it's not that bad. Okay. So I've just got a very silly example almost on the screen. I mean, there's 3 numbers that would give you absolutely zero like actually accurate analysis of anything in real life, but I'm just going to quickly show you how you would go about calculating this mess. Okay. And so very much like how you work out standard deviation, we have our lovely tricky table. Okay, our trick table, it is like our ace up the sleeve. And once you do the table, you're literally just plugging values into that equation and then working that out. So it becomes immediately much less intimidating. Okay, but before we start this, so just, yeah, so this is the example that I brought up earlier again. So just number of cups of coffee and test scores. We're going to see if there's some sort of correlation between those two variables. And I think it's important at this stage to also just get a knowledge check on independent and dependent variables. So what is an independent variable? You throw me some answers in the chat. Or even in this example, which one? Oh, well, they're labeled. Anyway, so yeah, what is the independent variable? The one that influences the other one? Yes, so it's the one that changes, correct. It's the one that changes, and the dependent variable is the one that you are actually measuring. It's the one you're testing. And yeah, a little phrase to help you remember this is that the dependent variable depends on the independent variable. Okay, so we're proposing in this situation that the test score could possibly depend on the number of cups of coffee consumed that day. Okay, so yeah, that's that kind of way of understanding those things, and it's entirely likely you could be given a scenario and asked to identify the independent and dependent variables with that. That's a very reasonable question. Could even be like a 2-marker. It could be even a 4-mark question if they're generous. You could get 2 marks, for identifying each one correctly. Yeah, so definitely do make a note and try to remember that. I mean, it's something that literally I still get confused about occasionally, and I've been doing this for so long. It's just my brain is like, which one's the independent one again? So that's normal. Don't worry. It's just, yeah, it comes down to just practice and finding ways to, yeah, remember things. Yeah, Cameron, absolutely. If you did biology, it is definitely, it is something that, yeah, would definitely have been emphasized a lot there. Okay, so let's get into it. Okay, so just like we do with the standard deviation, we build our table based on the things that we need in order to do our calculation. So just looking at the top line of this fraction, the numerator, we've got n. Okay, so you're always going to know what n is because it's the number of data points that you have, or the number of participants, or anything like the number of measurements that you have. So in this case on the screen now it's 3. So just to make a note of that. And then remember this this like big E is sigma, and it means the sum of. Okay, so what this whole thing in this bracket means is the sum of x times y. So that's why in the table at the end here I've got x times y. And just a refresher for maths literacy kind of stuff. When you have brackets in a formula like this, it means that the thing inside the brackets is self-contained. So it's saying this is one thing. This, what is the sum of x times y? And yeah, again, when something is directly next to each other in algebra, it means that they are being multiplied. Okay. So essentially, this at the top here would mean that you're going to multiply n by the sum of x times y. Okay. I felt like I just said a bunch of random letters in a row. It wasn't even like English. But anyway, we'll get there. It's about practice. Okay, and then so you're going to minus, and then what's here is these are two things being multiplied as well, and it's the sum of the x values, which will be, so it will end up being this block here, and then multiplied by the sum of the y values, which will be down here. Okay. Alrighty, and then if you look at the bottom, inside the square root, there's a bunch of brackets as well, but once you sub them in, they start to make more sense. We need squared things. Okay, so you can see just by the formula, you need to know what x squared is, and you need to know what y squared is. Okay, so therefore goes in the table. Okay, and the sum of them, right? So I guess let's dive in to just doing these couple little thingies. Right. Has anyone got their calculators on them to help me just make this process go quicker? If someone could put in the chat this column, so x times y, so what that would be, the first one would be 2 times 66. I mean, we can probably do that in our heads if, I don't know, if it was the morning and not a Thursday afternoon evening. And then 3 times 62, and then 4 times 78. Fill in the x squared, so that would be here. 16. Hey, hello, just checking if you guys are connected again, can hear me? Hey, yeah, it looks like everyone got booted for some strange reason. Sorry about that. We do appear to be back now. Okay, cool. Well, let's forge forward. Okay, so just to work out these y ones quickly, 66 squared is 4356. 62 squared, 3844. And then the last one, 78 squared. Goodness. 6084. Okay. Did anyone finish calculating the x times the y's? My chat just got deleted when we all rejoined, so if anyone wouldn't mind throwing those numbers. What is 3 times 62? It would be 180 plus 186? Yeah, okay. And then 4 times 78. That's easy to do in the head. Interesting. I think it is 312. 4 times 3. Yeah, okay, 312. Lovely. All right, so now what we need to do is add up all of the columns. Okay, this is randomly in bold. Okay, so I think let's just designate tasks here. Cameron, can you please add up X? Kirsten, can you add up Y? Landy, can you do x squared? I'm just looking at the most recent people who responded. Marita, can you please do y squared? And then who's next on the list of things? Ashlyn, are you there? Can you do add up the last one, the x times y? Yeah, literally just adding them together. Okay, I already forgot who I designated what, so when you post the answer, just say which one it is. But Cameron, I think you were the x column, right? Great. So 9. Wait, I'm being silly. It's not possible for that to be 29. 29 is the x squared one. This is just 9. Yeah. Okay. Have the y's. Oh, I see we have the y squared. Okay, 14,284. Whoops. XY 630. Yep. And what am I waiting for? Just the y's. What are the y values? 206. Yes. Okay. Excellent. Well done. Now we have all of the things that we need to sub into the formula. Oh my goodness, I keep hitting the wrong button. I feel like I'm going crazy. There we go. Okay, cool. So what I'm going to do now, the easiest way for me to do this is actually just to insert a slide and then draw on it. Okay, so we're going to do this whole nonsense now. Are we all ready? More importantly, I'm just going to show you how we insert the values. Okay. Let me just also copy this across. Oh, not the whole thing. Cool. Just pop that here for reference. Okay. Let's get subbing. All right. So what we do, we just get a pen here. Okay, so n, we know that n was 3, right? So we're going to just pop there 3. Now, we worked out what the sum of x, y was. It's this column over here. So that will be 630. Yeah, leave the brackets there because otherwise we get confused. Okay, 630, then we put the minus. Okay, the sum of the x values, got it here, it was 9. Which will be multiplied by the sum of the y values over here was 206. Oh, again, apologies for my digital handwriting. It's not that much worse for my normal handwriting. Okay, and always remember, guys, and this is something that happens under the pressure of exams and things, don't forget the square root, okay, after every step, because it's going to be pretty much the second last thing that you actually do in the formula, so just don't forget it. Okay. Right, so we have a square bracket, and then we have n again, so 3, and I'm going to put a bracket here just to help us with this situation. Okay, so what this means is the sum of the x squared values that we already have calculated. It is 29. Okay, and then minus. And now, does anyone spot the difference here between this and what that means? I know it's a little bit difficult to put into words, but essentially, so this is the sum of the x values, but this is the sum of the x values and then squaring that number, right? 3 comes from, there were 3 numbers. There were, well, 3 sets of numbers, so like 3 participants. That's where 3 comes from. N is always the number of participants in a study, or, yeah, the number of the data entries. Okay, sorry guys, I just saw a question and I went for it. Alrighty, so yeah, what we do then is when you see it in brackets, you do what's inside the brackets first. Absolutely. So that means it's the sum of the x values, which is 9 squared. Okay, so does anyone know what 9 squared is? Yes, Cameron, completely. Yeah. 81. Lovely. Okay. And just while we are here, let's do the same thing for the y, because we're going to need that in a minute. So we need to work out 206 squared. Anyone wants to pop that into a calculator quickly? It'll be a very large number. 42436. Okay, lovely. Voila. Okay. So now where were we? We were here. Okay, so we worked out the sum of x values squared, 81. We put that in here. And then close the square brackets. Okay, and then I'm just going to put it in here to remind you guys that eventually when we've worked this out, these things are going to be multiplied because they are just sitting next to each other like that. Okay, so we're now going to do the same thing but with the y values. So we've got n, sum of the y squared values was 29. Sorry, I forgot my brackets. There we go. And that will be minus this one we just worked out here. 4, 2, 4, 3, 6. Okay, first step done. Is everybody comfortable with where these values came from and how we put them into the formula? Because that really is the absolutely important thing to grasp. And the rest is really just solving the formula, which is a step-by-step situation. Okay. Cool, because if you can get to the point where you're really comfortable subbing values into a formula, you are aces in a way for this. Okay. So yeah, if you are required to do this calculation, you will be given the formula. Okay, so you don't have to stress about trying to memorize it. It will be provided to you. It will either be on a separate sheet or it will just appear there by the question where you need it. Yeah. Okay, let's do the next step real quick. Okay, so we need 3 times 630. I'm just going to break this down. Okay, 1890. Okay, we now need to times 9 by 206. Gives us 1854. Whoa, I said I didn't, 5 wasn't even. There we go. Okay, so then we've got over. Whoops. And then we don't forget the square root. If you say it as a mantra, it will stick. Okay, what is 3 times 29? 87. Okay, and then I'm not going to do this all in one step because I would like to get method marks. So I'm going to leave the 81 there and deal with it now. So, oh, sorry, I didn't sub in a 3 here for n. It's a 3. Okay, so 3 times 20. I did something wrong. Oh, I must apologize, everyone. My brain. Where's the eraser? There. This isn't 29. Oh my goodness. It is this value here. So it's 14 to 84. Sorry guys, it has been a long Thursday and my brain is a little bit on autopilot. Okay, and that's a 3. My square root disappeared. It's like the computer has a sense of humor. There we go. Okay, so we do in fact need to multiply that 14284 by 3. Okay, that gives us 42805. 0.52. And then minus, thank goodness, this is also like pretty much the same number. That's good, because remember, we're wanting to get an answer between -1 and 1. So yeah, if these numbers weren't similar, we'd be kind of anticipating a little bit of a problem. Okay, let's do the top one, and then that will sit pretty for a little bit. We've got 1890 minus 1854, 36. Okay, over the square root. Okay, so what is 87 minus 81? We'll do that. That is 6. And then 42852 minus 42436 is 416. Okay. I'm going to run out of space. Okay, 36 over. Now we need to complete what is inside here. So we've got 416 times 6 gives us 2496. Okay, I'm just going to shift to finish over here. So then, whoa, what is the square root? Goodness, I need another button on my calculator. Okay, the square root of 2496. Sorry, I forgot to rewrite the numerator. There we go. We've got 49.96, rounding to 2 decimal places. Okay. We are so close to our final answer. Would anyone love to do the honors? What is 36 divided by 49.96? .72, correct. Okay, and now the one for the money. What does this mean? So we have an R value of positive 0.72. What does that mean in terms of a relationship, in terms of the strength of the relationship and the direction of the relationship? I'm just waiting to get a few responses. Trust your gut. Okay, yeah, guys, excellent, well done. So, yes, it would be a positive because this is positive, okay? If there was a negative here for some reason in the calculation, then it would be a negative relationship, okay? I'm just making chaos for myself. Why do I do this? There we go. Okay, so if you had to then draw, and this is literally what it would mean, if you had to sketch a graph, you would show some kind of moderate relationship and positive. So there we go. Actually, it would be a bit steeper. It wouldn't be so like, it would be more like net. Okay, excellent. That is how you do that. So because it's a positive relationship, what would that mean in terms of this relationship between cups of coffee and test scores? Someone pop that into words for me. Because you will be asked that at the end of the day. You're never just going to end with the maths. You will always end with the interpretation of the answer. Yeah, correct. There's a positive relationship, so the more coffee, the better the results. Absolutely. And because it's I mean, it's a moderate to strong almost, right? So it's getting there. It's not like it's a 5, 0.5. So you could be fairly confident in that relationship. Okay. Excellent. I feel pretty confident that this is coming together. Yeah, Kirsten, absolutely correct. So as the one increases, so does the other. There is a relationship. Lovely. Okay, Karen's question. You mentioned that decimals can mean positive or negative in the start of the lesson. Can you repeat that? Hope that question makes sense. Oh, you mean the R values, like the answer that you get from the calculation? Yeah, so if we have a positive R value, so if this was any positive number, so in other words, on the number line, so if we draw like a little number line here, we've got 0, and then we've got -1 on this side, and we've got 1 on this side. So if the value falls anywhere here on the plus side, then that's a positive relationship. So yeah, it could be the 0.72, but even if this was 0.17, that's still a positive relationship, but that would be a weak relationship, right? Because that number is close to 0. Right, so conversely, if the number falls anywhere on the left of the 0, for example, if it was -0.17, then that would be a negative relationship. And the graph would look more like that. It would go down the other way. And it would mean that as the number of coffee cups increases, the test scores would decrease. And I mean, there's an argument for either of these things, so it makes sense. But does that clarify? Does that make sense? When in doubt, draw the number line, honestly. Never be afraid to draw any like little doodles and things that help you guys remember things. So yeah, so the criteria generally is that between 0.01, so not 0, and 0.4 is weak. Okay, and then if we have anything between 0.4 to, and this is why it's on the cusp. So between that and 0.7, it's a moderate relationship, or medium, whatever. But the word's moderate, but medium is the understanding, absolutely. And then if you have above that, so yeah, between 0.7, whoops, and 1, or really it would be like 0.9. 9 on that end, as close to 1 as it gets with 2 decimal places, then that is strong. And that's universal like understanding for that. So yeah, that's how you can understand that situation. Okay, question, would we be wrong if we just say positive, or does it have to be moderate positive? Okay, so you wouldn't be wrong, but you'd only get half the marks, because you always have to give the strength, which would be the weak, moderate, or strong, and the direction, which would be negative and positive. And the question may not even necessarily remind you of those things, right? They might simply say, describe the relationship if you get an R equals 0.94. It's always best to be specific. Always, absolutely. Excellent. Okay, lovely. Are there any other questions? I was going to have you guys do an example like in breakout rooms, but we just don't have time for that this evening. But what I will do though is I will take the memo slide out of here and I will upload these so that you guys can go and do that as practice. And then I will share the model answer. Okay. I'll share the answer. When should I do that? On like Monday. So go and practice while it's fresh over the weekend, and then in my Monday announcement, I will share the answer. So just when I upload the slides, this is the little example here. Yeah. I feel like everyone's probably trying to like zoom into the screen to see that. Nah. Anyway. Alrighty. I missed Cameron's question. Oh no. Let me scroll up. Oh, and the table, or we need to learn that? Okay, yes. So it's not specific that, so you won't be given the table unless whoever sets the paper is like the kindest person on the earth, right? So don't assume that you'd be given the table. Rather learn how to make the table for yourself. Yeah. And the best way to do that really is to just look at the formula that you need. Or, I mean, just memorize it. It's, yeah. So, yeah, absolutely best to learn the table format. Yeah. It's also depending on how the paper is set. So, the rule from last year, which I do believe will carry through, I haven't received the exam brief yet. But because it was a new one last year, it will be the same if, you know, past can predict the future. That you won't have to do more than one big calculation. So if they ask you to do this, essentially, if they give you data and they're like, work out the R value, then you won't be asked to also do a t-test, right? They'll do one or the other. They usually say that the exam brief is released about 2 weeks before the exam, which I know seems like super close. So yeah, I don't have it yet, but I promise you the second that I do receive it, I will share it on an announcement and post it. Yeah, what I'll do is I'll just send an email to the course coordinator person, the person who sets these things and sends them, to just ask, you know, prompt it a bit. Okay, so the funny E means the sum of, absolutely, it's the sigma sign. Okay, Almas, just before I get to your question on the assignments, are there any other questions to do with this evening's content? Okay, I'm just opening the assignments instructions on my end. Give me 1 second. I can't remember the exact wording in this moment. So many folders. I need to organize this nonsense. I feel like at this point, I just want to like pay someone to organize the folders on my computer. Is that a thing? There we go, assignment 2. Okay, I'm sharing the wrong screen. Oh. Share this tab instead. Aha! Alrighty. So the question is about question 2.3. Yes. Okay. So I want to be sure if I'm understanding right, we need to explain the independent and dependent variables, state which ones are which, and then talk about how we will measure them. That is exactly what you have to do. Absolutely, that is what is required for this question. So yeah, you identify which variable is which, giving that explanation, and then, yeah, how you will measure them. Okay. Would we mention the data methods essentially? Yes, so you will say how you intend to measure these variables. So for instance, if your title says you're trying to measure the relationship between the independent and dependent variable, whatever they are in your example, then the keyword relationship there means correlation, right? So you would say that you would um, end up running a correlation at the end, but then also how are you going to collect that data essentially is how you operationalize the variables. So like in my coffee and exam test answer things, oh, words, percentages example, then I would say that I guess I could record the amount of coffee that people take, consume on the morning of an exam, and then access the results afterwards. So really not an exciting data collection method, but yeah, essentially that is what is happening. How much detail in terms of how we measure? So I mean, not excruciating detail, just the main concepts, and just to identify essentially what that variable is, you know. So logically, then how would you collect data on it? What might be useful is what we're going to go over in the next thing, but like identifying the like level of data, that kind of thing, that can help determine what thing you're going to do to collect it. Okay, let me just see if I have missed any questions. So for example, we could say that we are going to conduct a survey with yes, close any questions, and a sliding scale 1 to 5. Absolutely, Luca, that is correct. But also just a note, sliding scale is like a colloquial term. They're called Likert scales. Okay. Could it be classroom observations? I mean, that's a qualitative data collection method. So I don't believe you'll be necessarily doing that with this one. Yeah, and this is an interesting thing. Like it's not that you can't find a way to argue qualitative in this one. It's just more difficult because you have to, do that kind of language conversion around it and make sure that you've argued sufficiently to justify your choices. Yeah. I don't know. It doesn't have to be a correlation. Don't stress. I'm not saying that's what the right answer is. It totally, and this is the thing with this assignment. It really depends on that title that you create. I think it's in this previous question right here when you have to give the title. Yeah, this one. But yes, qualitatively, yeah, you'd explain how observation would be appropriate to collect that data. Yeah. Yeah, the word count is restricting. I know it is. Yeah, I can't change it. It's really, it's not nice. It isn't. I mean, look, I can give some feedback. What do you not like about the assignment? Like, I mean, while we're here. Let me just stop recording and then I can, there you go. Everything. Okay, that's not really helpful feedback. Um, the wording is tricky. I mean, I agree. When I first saw this assignment, I thought, well, this could be explained a bit clearer, you know. I literally got the survey link today to give feedback on modules and things. That's why I'm asking. So if you guys have any like particular grievance with the assignment, it would help. You can always send me an email if you don't like think about it on the spot. Yeah, definitely the case study should be more detailed. Absolutely. That would definitely help. the word counts. Oof, yeah, I mean, I can give the the feedback, but I'm not sure anything will change with that one. Look, I mean, it's not supposed to be an easy assignment, you know. I mean, the first one was wildly easy, guys. Let's just be real. So it is. It's supposed to be a bit of a challenge, but no, there's room for improvement, and I will send that through. Maybe they will make some sort of adjustment for next. Mm. You know, that's a good point, Lindy. Actually, like I do feel that there's so much repetition between these two modules. I would love for them to make the research psych module more applied, you know, like specifically to psych kind of thing. Yeah, cool. I've got some good feedback. Thank you, everyone. What's the pass mark? The pass mark is 50 for everything. Pretty sure. 50%. It will be fine. Everything will be fine, guys. Don't stress too much. Okay. You have to find a research gap in literature and then apply it to the question for the research problem. Yes. Yeah, and look, this is I mean, really a wildly conservative literature review. If you're given a 12,000, I mean, 1,200 word limit, so get straight to the point. Yeah, cool, awesome, awesome. Definitely something for me to engage the people with who set these things. Lou's logging on. Okay. The exam, no, hey, the exam, it will be very much based on what the content is like. You know, the kind of case studies you'll get will be psychology oriented, but there's definitely room to make this far more specific to psychology. When will the feedback show? Oh yeah, because your marks have come out. Hey, why is that not showing? I'll send an email now so that hopefully they address it in the morning. So hopefully tomorrow. Yeah, no, look, the exam's going to be really mostly applying theory to scenarios. There's always that first section in an exam that are kind of like theory questions, like short answer situations. Um, yeah, but mostly definitely grappling with content and yeah, things. Okay, cool. I think that they've just forgotten to like open the eyes on the on your column in the thingy. I don't think I have access to do that, but I'll send through an email. Alrighty, thank you everyone. Yeah, if there are any issues, please do send me an email. But otherwise, I will see you when I see you. 3 weeks. I'll just hang around for Lou and her question. Yeah, sure, I can wait for a few minutes. For the theory part in the exam, yeah, it will be textbooky type things like that. I mean, it won't be like literally one word answers, but kind of, you know, maybe up to 5 mark questions, just defining things. That has popped up in the past. Trust, all of us marking would love for some multiple choice now and then as well. Types of sampling, possible. Explaining a particular type of sampling that would be appropriate to a case or a scenario, absolutely could come up. Oh, look, the paper last year was actually, I don't want to say surprisingly, but like pleasantly not difficult. In the sense that students that, you know, put the time in and studied and practiced sailed through it. You know. What other exams are you guys writing? Because there's no exam for REPR. Do you have community? Oh, abnormal. Ah, yeah, fair. That's stressful. There's no way to candy code that one. It's a hard module. Okay. I think it's also it's a very interesting module, you know, and I think it's very content heavy. It's one of those things. There just is so much content for it. There's not that much you can do. Yeah, also like you guys are so close to the end of the road now, you know. You can taste the freedom. Oh yeah, the DSM-5, like all the like, rules and things. I mean, look, I don't teach that module, so your lecturer for that would have to speak to what they could ask you in the exam for that. But it's also like it's not. They'll never ask you to like use a DSM to diagnose something in an exam, so you could probably, yeah, not get caught up on that too much. Okay, is Lou coming? Okay. I mean, if she's texting you, why not text the question and I can record it? Otherwise, email and I will do a response and like a good response in the morning. Cool. Sure, cheers. Hmm. Oh dear, my inbox has been a war zone lately. Do you know when the email came through by any chance? Yesterday, okay. Okay, cool. Just remember, 2 working days. I'm trying to find it. I don't see it here. don't see an email here. Maybe it didn't come through. Will you maybe just ask her to resend? And check it's the correct address. Yeah, I was super sure I'd replied to everything yesterday, or today from yesterday. Okay. Awesome. Well, yeah, sorry. I mean, I'm sorry she's having issues. I do have to run. But yeah, get her to resend that email that really genuinely hasn't come through here. But then I will give a response. Okay. No stress, no worries. Cool. Have a good evening.